In this video, we're going to go through graphing square root functions. So we're going to compare the graph that we're going to be graphing to f of x equals the square root of x, which is our parent function for a square root function. So let's go ahead and we're going to pull up our calculator so that we can graph. So we're going to begin by graphing y equals the square root of x, which is our parent function. And we see that that's what our function looks like. So if we were to graph our parent function here on graph A, which says g of x equals the square root of x minus 1, our parent function is going to look like that. So now in our calculator, if we put into the next spot the square root of x minus 1, and we hit graph, now we see that our graph is kind of shifted to the right a little bit. So we can say that that moved to the right one spot. So that was our comparison to the parent function. Now for letter B, we know our parent function is going to be the same. That's not going to change. But now we're going to pull up our graphing calculator, and instead of having the square root of x minus 1, we're going to have the square root of x, then subtract 1. When we graph that, we see that now it's moved down. So when we sketch that here, we can say that that moved down one place. So let's look at letter C. Again, we know what our parent function is, so we can graph that right away. And now we're going to plug into our calculator 2 times the square root of x. So we're going to go into our y equals, and we're going 2 times the square root of x. Let's see how that changes our parent function. Wow, that looked like it kind of went up and it rose up pretty fast. So when we draw that, we're going to say that that's a vertical stretch by 2 because it stretched it up vertically. Now for letter D, we have g of x equals negative 2 times the square root of x. So we can graph our parent function. And now we're ready to graph our negative 2 times the square root of x. So go to our y equals. We have our parent function. Then we need negative 2 times the square root of x. And we'll graph that. And this time, although it still looks like it's wider, farther away from our x-axis, it's also kind of upside down. It's on the other side. And we call that a reflection. So this is a reflection over our x-axis, and it's a vertical stretch by 2. So how do we know how to compare and what words to use? Well, if we take a look at our formula here, our generic formula, you'll notice some pieces. We have a negative a times the square root of negative m times x minus h plus k. And each piece plays a part. So the h controls our horizontal translations left or right. So it moves the graph left or right. So in our example here, a minus says that we're going to go right 2. Whereas if I see plus 3 inside, I'm going to move to the left 3. So when anything's on the inside, it does the opposite of what we think it's going to do. Now the k controls our vertical shifts, so meaning moving up and moving down, not stretching it, but moving it up and moving it down. So here we have the square root of x plus 7, and that's going to go up 7. Notice that the 7 is not on the inside with the x. So it says 7 plus 7, so we're going to go up 7. We have the square root of x minus 1. That means go down 1. Now the negative signs. It depends on if the negative is on the inside or on the outside. If our negative is on the inside, then we're going to reflect across the y-axis. But if the negative is on the outside, then we're going to reflect across our x-axis. The m controls our horizontal stretches and shrinks. So it either moves towards or away from the y-axis. Now this one's on the inside, so it's going to be the opposite of what we think should happen. Because the square root of 3x, we think that that should be a stretch. But really, that's going to be a horizontal shrink by 1/3. So we're going to be using the reciprocals of the numbers. For the square root of 1/2 x, we're going to be horizontally stretching this by a factor of 2. Our A value on the outside controls our vertical stretches and shrinks. Because it's on the outside, if it looks like it's going to stretch because it's a big number, then it's going to stretch. Like for example here, we have the g of x equals 4 times the square root of x. Well, that's going to be a vertical stretch by 4. And our g of x equals 1/5 times the square root of x will give us a vertical shrink by 1/5. So let's kind of put that to use. We're going to do some examples, and for each of the functions, we're going to describe the transformation from the graph f of x equals the square root of x, which is the parent function, so how does it change? Then we're going to sketch the parent function and the given function. So for example, in number 1, it says g of x equals the square root of 8x. So the 8 is on the inside, so that tells me that I'm going to have a horizontal shrink by 1/8. So what does that look like? Well, if I sketch my parent function, that doesn't change. So I'm going to move towards the y-axis. Notice how it got taller. And it's just a sketch. So for number 2, I have g of x equals 4 plus the square root of negative x. So the 4 on the outside means I'm going to be moving up 4. And the negative on the inside means I'm going to flip or reflect across the y-axis. So my parent function didn't change, but I'm going to go up 4 and then have it go on the other side of the y-axis. Let's do a few more. Here, for number 3, we have y equals the square root of x plus 4. Which direction do you think that's going to move? Check your chart if you need to. Did you say to the left 4? Then you were right. So when we graph our parent function, again, it didn't change, but now we're going to move it to the left 4, and so our graph would look something like this. For number 4, we have h of x equals the square root of x plus 9. Because our 9's on the outside and it's in the k's spot, that tells us that it's going to be moving up 9. So our parent function will look like this, and we're simply just going to move our function up to show up 9. Let's do 2 more. So these ones look a little bit more complex. There's a little more to them. So for number 5, we have f of x equals the square root of 1/2 x plus 1. So let's look at each of the pieces. We have the 1/2 on the inside and the 1 on the outside. So the 1/2 on the inside tells us that there's a horizontal stretch by 2, and the 1 on the outside tells us that we have to move up 1. So here's our parent function. So we're going to horizontally stretch this by 2, so we're going to move away from our y-axis, and we're going to start up higher. So notice that we started up a little bit higher, not on the origin, and then we moved away, so we're a little bit flatter, because we moved away from our y-axis. For number 6, we have f of x equals 5 times the square root of x plus 2 minus 1. So the 5 on the outside tells us that we're going to have a vertical stretch by 5, so it's going to stretch it up. The plus 2 on the inside says that we're going to move to the left 2, and the 1 on the outside says that we're going to move down 1. So we have our parent function. Then we're going to move left 2, down 1, and we're going to be stretched up nice and tall. And this is what our graph is going to look like. Remember that you can use your graphing calculator or Desmos to help you graph these and see the differences between the function and the parent function. But knowing how your chart works and being able to identify the pieces is going to go a long way in helping you describe the movements of the graph.